Okay, now we'll move on to another variable type, and this is probably the most important variable type that we'll encounter with R, and these are data frames. So a data frame is like a worksheet of values organized with instances as rows and different value types as different columns. You can think of this like an Excel worksheet where it's a two-dimensional box, essentially, of data. But with R, all columns must have the same number of rows. So whereas Excel, there's no limitations on, or no requirements for all rows having the same number of columns and all columns having the same number of rows, R does have that requirement. So with R, all rows must have data for all columns, and all columns must have data for all rows. So remember, vectors were essentially one-dimensional. It was just a string of values, whereas a data frame is now two-dimensional with rows and columns. To show you some of the nature of data frames, we're going to use a file called agefat.csv. You can download this from the course Brightspace page, and then to use it, you need to set R's working directory to the folder where you have saved this agefat.csv file, and then you'll be able to read it into R, and I'll show you the commands for how to do that in a minute. This file contains age and body fat percentages of 25 adults. And the data look like this. So it's a data frame. We have one column that's just an identifier for each individual, another column that has that individual's age, another column has each individual's fat percentage, and then the last column has each individual's sex. So here, each individual is a row. The data for each individual is a row, and then the different data types are the columns. So each row contains data for a different individual, and each column contains a different type of data. So note that it's two-dimensional, and with a data frame, each column or field can have a different data type. So for example, these two columns are both integers, but this column has what are called floating point numbers because they have decimal places, and then this is text. This column is text. So data frames can have columns or fields with different data types. So you can read these data into R with this command. So here we're going to create a new variable called AFData. We're going to assign to it this information. So the command to read data into R is called read.table. And then in parentheses, then we have in quotes the name of the file that we want to read in, so agefat.csv. Another argument we need to put in here is we need to tell R that this file contains a header, right? So the first row of this file does not contain data. Instead, it contains heading information. So we need to tell R that. So we're saying header is true, and then we have to tell R what character is separating the different fields. So this is a comma-separated file, so the fields are separated by commas. And so we type sep equals, and then in quotes, whatever character is separating the files, and in this case it's a comma. So if you type this into your command line after setting R's working directory to the folder that contains this file, once you hit enter, you won't see anything, but you hopefully won't get any error messages. But now you'll have this new variable that's going to contain this information. So if you look at RStudio, once you've typed in that command, you should see, so I actually called this something different. Yours would say AF data, right? So yours would say this, and I apologize for that difference. So yours would say AF data here, and if you click on that, it should open it up as a table over here. So you should be able to see the values, and you can scroll through them that way. So this is another nice characteristic of RStudio, right? This will show you a list of all of the variables that you have, and if you click on them, it will open them up in this window, and you can see them. So with a data frame, you can refer to specific parts in two different ways for now, and we'll learn some others later. The first way is using the field names, and the second way is using row and field numbers. So we'll walk through these. So the first way you can do this is you can refer to a specific column or field by using this format, the data frame name, and then the $sign, and the field name. So for example, our data frame is called AF data. And so if we want to refer to the individuals, we can just do AF data $end. So if you type that into the command line, and please do this, and then hit enter, it will give you all the individuals. Similarly, if we want all the data for the ages, you can type AF data $age and hit enter. Again, please do that, and it'll show you all of the ages. And you can do this with any column, right? So again, the format is the data frame name, $sign, and then the field name. And that's one way you can separate out different columns of data in a data frame. You can also refer to specific rows and columns and cells using brackets. So remember, with vectors, we put in brackets the position number that we wanted to refer to. Of course, data frames are two-dimensional, so there's two different positions here within the brackets. The first position is where we put what row we're referring to, and then a comma, and then the second position is where we put what column number we want to refer to. And if you leave it blank, R interprets that as all. So this kind of sounds abstract, so let's get some practice. So if we want the data for the first individual, we can type AF data, and then this is saying we want all the data for the first row. So we put 1 in the row position and leave the column position blank, and that means all columns for the first row. So again, you should type this into R and hit enter, and you should see that it'll show you all of the information for the first row. Similarly, we can do that for the second row, the third row, and so on. We can do the same thing for columns. So let's say we want all of the data for the first column. So we want all rows, so we leave the first position, the row position, blank, and then comma, and then a 1 to indicate the first column. And so that will give us all the data in the first column, or the second column, or the third column, or the fourth column, and so on. So now, if we were all together, I would ask you, and hopefully we can have a discussion, about how would we refer to this position. Hopefully you can see this is a specific row and column. So we'd refer to this as AF data, so the data frame name. Then in brackets, we want data from the 6th row and the second column. So it should be AF data brackets 6, 2, right? And this would work. So if you type this into your command line, you'll get the value 39, because that's the value that's located within this position of our data frame. So we can refer to more than one position essentially by treating each position as a vector. So we can use that C for combine command, or the colon to refer to specific integers, and essentially treat each column and row position as a vector to specify which ones we want. So in this case, we want rows 5 and 6 and columns 2 and 3. So we could refer to these values as AF data. Then to specify the rows, it's rows 5 to 6 and columns 2 to 3, and that would give us just these values. Now, you can also add logical arguments to these, and this is where R can get pretty slick when it comes to parsing out different parts of your data. Excuse me. So for example, we can use these different symbols to mean different things. So if we want to say equal to, remember we can't use just the equal sign because that's assignment in R. So to say equal to, we use 2 equal signs. To say not equal to, you use an exclamation point and then an equal sign. Then greater than, less than, greater than and equal to, or less than or equal to. And then the ampersand is for and then this is called a pipe, means or. And so we can use all these to parse out different types of data from a given data frame. And so we'll walk through some of these for examples. And again, you should type these in as we go. So for example, let's say we want to parse out all the data for males in this data frame. Well, so we refer to the data frame. And then for our rows, we want to select out which rows have male in the sex column. So here in the rows, we specify, so we're in the row position of the brackets, but we want to refer to a column, right? So we wanted to know which rows have in the sex column equal male. And so if you type this in, it'll show you the data for just males. And hopefully that makes sense to you. If that doesn't, kind of walk through it slowly until that makes sense. So we do the same thing for females, right? All we do now is just change male to female here. And this can be a little bit tricky, right? Because we want the rows of data, so we want all the rows where the column sex is female. So that's kind of how this can get confusing. So we could also say, okay, well, I just want the data for everyone 30 or older, right? So here we want all the columns for the rows of individuals that are greater than or equal to 30. So we want the age data, those rows where the age data is greater than or equal to 30. And so again, if we were together, I'd say, well, how would we get the data for all males who are 30 or older? So what I'd like you to do is pause the video and see if you can figure this out for yourself. And then only after you've struggled with it, come back to the video and see what the solution is. So here, this is starting to get complicated. So we really have two criteria. So we want data for males that are 30 or older. So we want the values where the sex column is male and the age column is greater than or equal to 30. So again, we set this out. We're specifying what rows we want, and we want all columns of our AF data frame where the sex column equals male and the age data is greater than or equal to 30, right? And so that will parse out all the data for males 30 or older. We could also change it so data for all males or individuals that are 30 or older. And so here the sex is the same, so AF data sex equals male, or individuals that are over than 30. So of course this over than 30 now is going to give us females, right? So it's going to give us the data for all males or individuals that are over than 30. So it'll also give us the females that are over than 30 with this query. Okay, so again, try to pause this video and see if you can solve this one on your own before going forward. So how could we get the data for all males or females that are 30 or older? Okay, so this is getting more and more complicated, right? So again, our AF data frame, and we're specifying rows, right? So it's before the comma, but we want all the columns for these. So data for all males, so we want those rows where the sex column is male, so AF data sex equals male, or females 30 or older. So the 30 or older criteria only refers to females. So we need to put those in parentheses to make sure that they go together, right? So to specify females, so we said AF data sex equals female, and the AF data age is greater than 30, right? So this will give us all males or females over the age of 30. Okay, with the parentheses here. So hopefully this makes sense. And hopefully by doing this, you can see that R can be very powerful for subsetting out data sets in different ways. And this is very, very useful. Okay, I think we'll stop there before moving on.